Hello, my name is Mary Nall, and I'm presenting my final presentation over flyer plates. My mentor is Joanne Budson, and I want to gratefully acknowledge the funding from Los Alamos National Laboratory. So flyer plates help us understand material properties. The left figure shows a 2D figure of a 3-layer flyer plate, and it's showing how it's going to hit the target. My flyer plate is only 1 layer, but this is just simulating how the flyer plate will hit the target. The right shows the velocities accessible to various types of launchers, so it just shows how fast we can make the flyer plate go depending on what type of launcher we use. So we will be launching our flyer plates at 1.5 kilometers per second, which is 3,400 miles per hour. So I used Abacus to simulate the flyer plate and target. And the reason why I chose Abacus is because it's commonly used in the industry. Abacus is a software package for finite element analysis. This program allowed me to simulate the flyer plate and target to collect data. The output properties I'll be looking at are force, strain, displacement, and velocity. So this is just showing the materials and the different properties of the flyer plate and target. So the target for both sessions, when the flyer plate is steel and when it's aluminum, the target is staying steel. And we've listed the material properties for aluminum and steel, as well as we have the difference in dimensions of the flyer plate and target. Both flyer plate and target did stay the same in thickness. The starting distance between the two is 100 millimeters, and each body is 1 layer thick. So this is our results. We found that the aluminum flyer imparts more force. Aluminum gives off more force on the target, but in less area, as shown in these lines here. The lines kind of come together and it's not very thick. And these lines are located on the sides of the target. But when we look at steel, though it doesn't give as much force, it only goes up to 50 newtons. This area is a lot thicker, so it does cover that force in more area. And these weird lines here seem to be located mainly toward the edges. So the flyer plate material made no difference in the max logarithmic strain. So we can see here that it stayed constant, and the reason being is because the target had it was locked in. It couldn't move. So when the flyer plate hit it at the 1.5 kilometers per second, this is showing proof that the target had no movement, so it was still during that impact. Which is making the max strain constant. So we did find some interesting features near the edges in the minimum strain. So what these zigzag lines are showing is where yielding is happening but it's not increasing the stress level, and this is happening on the sides of the target. And it's the same for both when both the aluminum flyer hit the target and the steel flyer. So steel overall puts more stress on the target. The highest stress for both aluminum and steel is on the sides. Steel is showing to have the most stress on the sides, showing that this is here is thicker than aluminum. And it's also putting more stress on the target overall, as seen in there's a lot more lines and a lot thicker areas than aluminum has. But both metals are causing the least amount of stress toward the bottom of the target, as we can see here. So personal growth, to start off, I want to thank Los Alamos National Laboratories and Texas A&M OREU program for giving me the opportunity to learn the basics of research. What I learned is that research it generally takes a lot of time and patience to get through, and I had to start from scratch and learn 3 new programs. The advice I would give someone starting a project like this is don't let it overwhelm you. Just keep working at it and things will fall into place. So what I learned is flyer plates are very useful for testing materials under extreme conditions. This type of experiment allows us to see how a material will act when it's being hit at extremely fast speeds. Once I learned how to use Texas A&M HPRC, I was introduced to many useful resources for my project. Abacus was the most useful. That's how I simulated my flyer plate and target, and that's how I obtained my results in my graphs. Slurm and Bash was how we called on Abacus to create the files needed for my graphs to be created. And I also used gedit for the coding. Thank you.